Let's talk real quick about MCRTs. I did an introductory video about the difference between sludge age and MCRT. I will pin in the comments down below. Also, with respect to the pounds formula, I will put in the description a link to my wastewater process video. About, I don't know, 2/3 of the way through that video, you'll find the pounds formula in the Davidson pie method. I use that method, but in a more linear fashion in this video. I will do a more extended version of the pounds formula at a later time. Maybe by the time you stumble upon this video, I'll have that new video in the links below as well. But if you're unfamiliar with the pounds formula, please go review it because you need it for this math equation. Okay, so all the MCRT is 3 pounds formulas. Some equation sheets and conversion sheets show it as 4-pound formulas. I think that is one extra step than you need in your life. So let's break this down real quick before we work the math out, and you can kind of see how this works. Okay, so you are going to divide the amount of MLSS in pounds in your entire secondary system by, you're going to divide all that by the MLSS leaving the system by calculating pounds per day and WAS plus your effluent TSS in pounds. So before I go any further, for math's sake, MLSS equals TSS. Okay, operators, I know MLSS is much more than that. The mixed liquor suspended solids means something else in a biological way, but for the sake of the math, I like to teach it like this because it really demystifies how we get why TSS is even involved in this. Okay, so when you send your samples to the lab, you want to know what your MLSS is, you write TSS on the chain of custody. Unless you've got an internal lab that knows what you're talking about, most third-party labs are going to look at you funny. You write TSS on your samples. Okay, so just pretend, for the sake of math, when you see MLSS, you're talking about TSS. That's why you add this together. All right. So if that was confusing, please ask more questions in the comments. I'm happy to assist. Find me on LinkedIn, message me. I can explain what I'm talking about, but that's why I like to teach it this way. So the other thing is the MLSS in aeration is going to be the MLSS in the secondary clarifier if the secondary clarifier was mixed up. That's why you only see one MLSS up here. That's why adding the volumes together and then doing your pounds formula instead of doing 2 separate pounds formulas makes sense. Okay, if you have questions about that, please put it in the comments below. So now that we've given you an overview of what the actual equation is, I want to talk to you over here about a couple key items. First, Q means flow. Get to know that Q means flow. That's how it's going to show up on your 3s and 4s tests, Californians. They're going to stop saying flow. They're going to start writing Q. So just know that. The WAS concentration. I want to talk about that real quick because when I was studying for this and I wasn't working in an activated sludge plant, I had no idea what this stuff meant. And why was the MLSS in aeration 2250, but the WAS concentration is 8,000? How in the hell does that happen? Well, how it happens, and you know, I haven't done an activated sludge video yet. I will link to that in the description once it's up and running. But in that video, I intend on doing a set solids test, and you'll see that when you go into a secondary clarifier, the solids settle, okay, to the bottom, and clear water stays on the top because the MLSS creates what's called flock, and it kind of imagine a net grabbing it and pulling it down. Well, that 2250 compacts on the bottom of the clarifier in what's called the sludge blanket, and a bunch of clear water stays on top. So your concentration of the sludge triples, quadruples sometimes as it gets down into the lower part of the clarifier. That's where that concentration comes from. Pro tip, the WAS and the RAS, return activated sludge, concentrations are typically the same because they're typically pulled from the same place. I'm only mentioning this if you're skipping my activated sludge video because you just want to know the math. boy, would I have loved to have known that, because I worked in a trickling filter in an RBC plant for the first couple of years of my career as a wastewater treatment plant operator. I had no idea what any of this meant. Okay, so with that, I'm going to move to I'm going to edit the video here. I'm going to wipe all this away. There's just not enough room on the board to work the math problem out at this point, and we're going to work that math, and I'll show you what an MCRT looks like. Okay, let's work our math out here. So I've got 1.2 million gallons in my secondary system. So my aeration volume is 1 million gallons. My secondary clarifier is 200,000 gallons, or 0.2 mg. So that's 1.2 million gallons. Add them together. Remember that MLSS concentration is going to be the same through the whole secondary. It just depends on how it's dispersed in the secondary clarifier. So I multiply by 8.34 pounds in a gallon. That's a constant. That's 1 gallon of water weighs 8.34 pounds times 2,250 milligrams per liter. So that brings me down here, and I've got 22,518 pounds of MLSS in my aeration basin. So now I'm going to do what's leaving the plant. So I've got my WAS flow is 0.05 mgd, or 50,000 gallons per day, going somewhere. So I've got 0.05 mgd times 8.34 times 8,000 milligrams per liter WAS concentration. Some thick stuff going to a thickener or something. And I've got to add that to my plant flow, 3 million gallons a day, times 8.34. Notice a pattern. Times my effluent TSS. My effluent BOD is irrelevant, means nothing. We're talking about TSS here, of 8 milligrams per liter. Okay. So this right here comes out to 3,336 pounds per day plus 200 pounds per day. Work this out in your calculator. If you get something different, let me know. We'll work on it together in the comments section, see if we can figure it out. But then I get 22,518 pounds. I'm going to carry that down, and then I'm going to add these two together, and that gives me 3,536 pounds per day. I divide that, and it becomes 6.4 days. That is my mean cell residence time. On average, microorganism is spending 6.4 days in my secondary system. This is indicative of conventional activated sludge. You need to know about that. Advanced test takers, you need to know why this number matters. The shorter the duration, the more explosive growth you'll get. And this kind of gets into food to microorganism ratios. All these math concepts really start tying together eventually. But just know that 6.4 days is on the lower end of conventional activated sludge, and you're not doing much more than BOD and TSS reduction here. You start getting into like 20, 25, 30-day extended aeration kind of situations. You're starting to nitrify and do other cool biological processes, but it comes at your peril if you're not watching it, because things can get off the rails if you're not in control of your process with running MCRTs that high. So I hope this helped. Please ask questions in the comments below. Advanced test takers, you're going to be given the MCRT, and you're going to need to figure out your wasting rate. So grade 3s and 4s, be ready to find WAS-Q. And it's just really reverse engineering this equation. And I'll do another video on that. I'm not going to fill this up with all that stuff. And we'll go from there. So any questions, please ask. If you want me to work out a different math problem, please ask. And I am happy to help. See you in the next one.